Automation of operation and management of distribution network, or they may ask explain outage management system, or DMS explain monitoring and operation of electrical system monitoring. So in system monitoring, what it will do, it will compare the measured data. That means measured data means from the many equipments what we collected the data, that is the measured data, and they compare with the normal values or limits. Okay, it should not go above the limit. So it will check if any abnormal, then it will if it is abnormal change in the real time measurements, it will generate an event that triggers automatic control functions, or it will notify to the distribution network operator. Deadband is used to filter out normal and small fluctuations of the measured data. Of system monitoring, distributed network operator, DMS, that is distribution management system, SCADA, supervisory control and data acquisition, distribution network, fed to smart metering. So this is some are bidirectional. Manual update network information, it will go to the DMS, and real-time measurements to the distribution network, and manual operation. Okay, here next it is the instructions. Next is a system operation. So in system operation, first is a network reconfiguration. In network reconfiguration, supply restoration. Okay, so here this is a optimally restores electricity to customers using alternative sources. Application is a part of the fault location, isolation and supply restoration function. Here, active power loss minimization at a given time, or energy loss minimization over a period of time. Load balancing between different feeders or transformers and equalizing voltages. Which methods they use? The methods for network reconfiguration is practical experience and mathematical methods and computational intelligence based methods, that is hybrid methods, which combine two or more methods. One is practical experience, mathematical methods, computational intelligence methods and hybrid methods. Okay, these are the four methods used for the network reconfiguration. Volt or VAR control, that is reactive power control. So usually this is used to improve the voltage profile and minimize network losses. So what voltage and VAR control, so you can observe the optimal set points of the voltage controller, that is open load, on load tap changer, okay, voltage regulator, distributed energy resources, power electronic devices, capacitor status and demand response. These things we need to calculate, okay, in order to control voltage and VAR. Once again I repeat, voltage controller of open on load tap changer, that is voltage regulator, distributed energy resources, power electronic devices are required, and capacitor status and demand response, how much it is. For example, reactive power control, if they are using a inductive loads, then it will absorb more reactive power. Okay, so in that case they need to use a capacitor banks. So how much the reactive power is absorbing, so how much capacitor banks should be installed. So next is a relay protection coordination. So when we use any protection devices, so it should be coordinated with the equipments. Here this is accomplished through analysis of relay protection setting and operational modes of circuit breakers while considering the real-time network connectivity. So when we come across with the protection, it will be connected to the many equipments, okay, circuit breakers, relays. So while considering the real-time network connectivity, coordination with the distributed energy resources and microgrid and weather conditions. So these are the come under the relay protection coordination. So here operation of DER, distributed energy resources. The presence of DER in the distribution network can significantly alter the flow of fault current. So for example, two lines are there. One is a fault current. So this line can be overcome by the using the DER. Okay. So here the presence of DER in the distribution network can significantly alter the flow of fault current and change the source of ancillary service. So the operation of DER needs to be integrated to the DMS to guarantee reliable system operation. So here, for example, this is a thermal. There are two lines and one is from the DER. Okay, one line is from the DER. So load should get supplied. Okay, so in case if it is a fault, okay, so the supply will the alternate source is DER, then that will be connected to the load, so they get a continuity of supply. So that is what they are saying here. The presence of DER in the distribution network can significantly alter the flow of fault currents and change the source of ancillary service. So the operation of DER needs to be integrated to the DMS. So in order to manage demand side management, okay, distribution management system, to guarantee reliable system operation, so it should be integrated with the distribution management system in order to what? In order to guarantee a reliable system operation or continuity of supply. So system management, this is the third application. So first is a and system operation, system management. Here system management, automated mapping, facilities management, that is AM, FM, automated mapping, facilities management, geographic information system. So here AM, FM, GIS system, that is graphical components, means here shapes or geometries. Database components means stored data. The outage management system is a system which combines the trouble call center and DMS tools. Why they use DMS tools? To identify, diagnose and locate faults. First we need to identify, okay. Next it is diagnose, which from where it has been occurred, through which, so it will be diagnosed. First identify fault, okay. Next diagnose from how it is occurred, okay. So how it is occurred and from which equipment it has been occurred, what is the cause for that, and next locate, where is the location of the fault. Then isolate, that means it should be separated, okay. Isolate the fault and next restore supply, okay. After clearing the fault, again it should be connected to the line. So this is the figure for that trouble call entry. Next trouble call database. First information through the call, through the telephone or voice communication or automatic voice response system or automatic outage detection or SCADA detection or circuit breaker trip lockout, okay. However, we will come to know fault is there, okay. Through, it may be through the telephone or it may be through the voice communication or it may be through the automatic voice response or it may be to the automatic outage detection or through SCADA detection or through circuit breaker, okay. So these are the sources how we come to know there is a fault, okay. Trouble call entry, trouble call database. Next fault diagnosis. Fault diagnosis is based on the group of customers trouble calls. So here based on the trouble calls, they use a reverse tracing of the electric network topology. They go to the electric network topology, okay. They trace where it may be as occurred, fault where it will be occurred. They diagnose to the fault, okay. By considering the call database, they diagnose the fault using a electrical network, okay. Next outage will be calculated including the number of customers affected and priority of the affected customers, okay. So here what happens means outage will be calculated, fault will be calculated including the number of customers affected. So number of customers affected, and the priority of the affected customers. For example, 100 customers will be affected. In that, the priority of the affected customers may be 20 or 30, like that. Okay, so how many of them? Priority of the affected customers. Information or modification of the fault diagnosis and its location is based on the feedback from field crew. Okay, so it's based on the field crew. So the trouble call solution is widely used in the United States for medium voltage networks. Next is a supply restoration, fault identification, next fault diagnosis and location, and next is a supply restoration. Here remedial action depends on the severity of the problem. We cannot restore all the problems or all the faults within a seconds or within a minutes. Okay, so if it is a minor, it will be get back to the normal within a minutes or hours, like that. Okay, so it depends upon severity of the problem. Okay, remedial action depends upon the severity of the problem. If the fault is a simple problem, the field crew can make the repair and restore supplies in a short time. So if it is a minor fault, so for example, line has been cut down in summer days, during the rainy seasons, wires will be in season or rainy seasons, so some lightning has been occurred, so any problem in the pole or any problem in the transformer, it has been tripped due to the overload. So in only small faults, if the fault is a simple, then problem can be repaired, restored, supplies in a short time. Okay, maybe tripping in the transformer, or it may be a line to line fault. Okay, or it may be a line to earth fault. Okay, so it depends upon the fault, which fault has been occurred, and if it is a simple, it will be restored within a simple time, short time. If the fault causes a major outage, after the isolation of the faulted area, the unfaulted portion will be restored using a normally open points. So in that case, here it will be isolated, it will be separated. Okay, faulted area will be separated. You can observe transformer installation. During a transformer installation, for example, transformer has been get damaged. Okay, totally it is not working, then during the replacement, okay, we cannot do the alteration for that. For a particular load, it will be a interruption of supply. So if the fault causes a major outage after the isolation of the faulted area, so in that case, for that particular area, they will remove the supply, and after the installation of transformer and after charging it is, they will give the supply to the particular area, affected area. Okay, so the unfaulted portions will be restored using a normally open points. Automated fault detection, isolation, restoration schemes with feeder automations are widely used. So automated fault detection, so variations in the voltage, variations in the current, or it is a frequency, for example, automatic voltage relay, automatic current relay. Okay, so if any minor variations or fault detection, automated fault detection, it will compare with the normal value and it will detect and it will be identified. Automated fault detection, isolation, okay, and restoration schemes with the feeder automations are widely used. Next is event analysis and recording. It is more important. Any outage event will be analyzed and the information kept as a historical record to record the cause, number of customers affected, and duration. Why we need analysis, event analysis? So any fault we will not come to know. So now we are studying the books, these faults has been occurred. So we came to know the how to solve and what are the methods to solve and how it has been occurred, what is the reason for that, right? So it is a historical record. Okay, now what we are studying in the books is a historical record, because they have analyzed through the outage event. Okay, they have gone through the faults, how the fault has been occurred and what is the reason for that, because of this historical data. Okay, outage event will be analyzed. Okay, first it will be analyzed and the information kept as a historical data. For future purpose it will be helpful. Okay, so in this area it has been occurred this fault. Okay, maybe due to this reason. So in order to avoid that, which equipment should be kept? Okay, which equipment we need to use and how to avoid that faults. Okay, so based on the analysis or based on the historical record only we can decide, right? An outage event will be analyzed and the information kept as a historical record to record the cause, number of customers affected and what is the duration. Okay, so for some particular areas there will be many trip. Okay, transformer will be tripping. Okay, more because of overload. Okay, so why it is occurring and what is the reason? Okay, so how many loads are there, what is the load consumption? Okay, so everything based on the historical record. Okay, in future how much it will affect, such information used for calculating performance statistics. So without information we cannot calculate the performance statistics. We need a information to calculate the performance statistics. Benefits from integrating smart metering and outage management are derived from crew and dispatcher efficiency saving, reduction in restoration cost and reduction of outage duration. So if we use a smart metering and outage management are derived from a crew and dispatcher efficiency savings. Integrating the smart metering and outage management are derived from a crew and dispatcher efficiency savings. This will reduce a reduction in restoration cost and also reduction of outage durations also. Nowadays they want to, so the research is going on in the smart grid. So if it is a two-way communication, if the losses will be reduced and the efficiency will be more. Here reduction of outage durations, the main thing is faults will be reduced. Okay, and the energy